In the world of distributed systems, the CAP theorem is one of the most fundamental concepts for understanding how data behaves when spread across multiple machines. Proposed by computer scientist Eric Brewer in 2000 and later formalized by Gilbert and Lynch in 2002, the theorem explains a critical principle. This realization changed how engineers design large-scale systems, from databases to cloud platforms, by defining unavoidable trade-offs.
It highlights the crucial balance between reliability, speed, and fault tolerance in these complex environments.
Let's delve into understanding the three core properties that form the CAP theorem's foundation.
Consistency means that every client sees the same data at the same time, no matter which node they connect to.
After a successful write operation, all subsequent reads should return the exact same updated value across the system. This is similar to how a single database on one server behaves. When you change a value, every user sees the change immediately.
Availability ensures that every request, whether a read or a write, receives a response, even if some nodes in the system have failed.
The system might not always return the most recent data, but it always remains operational and responsive to user interactions.
Availability is critical for user-facing services where downtime can cause significant frustration or substantial revenue loss.
Partition tolerance means the system continues to function even if communication between parts of the network fails or delays occur. In distributed environments, partitions, which are temporary breaks in network connectivity, are an inevitable reality. Without partition tolerance, a single network issue could potentially bring the entire distributed system to a complete halt. Now, let's explore the fundamental trade-off at the heart of the CAP theorem. The CAP theorem states that when a network partition occurs, a distributed system must choose between consistency and availability. It cannot fully guarantee both at once, forcing designers to make a critical decision. A CP, or consistent and partition tolerant, system sacrifices availability. It ensures that all nodes return the same data, but during a partition, some requests may fail or time out. Traditional relational databases or systems like HBase and MongoDB in strict mode often lean toward this CP model. An AP, or available and partition tolerant, system sacrifices strict consistency.
It continues to respond to requests even during network issues, but some nodes may temporarily return outdated data.
Systems like Cassandra, CouchDB, and Amazon DynamoDB typically follow this model, offering eventual consistency. A CA, or consistent and available, system can exist only when there are no network partitions, which is rarely realistic in large distributed environments. Thus, in practice, every real-world distributed system must be partition tolerant and then choose between consistency or availability as the second priority. Understanding CAP helps engineers design systems based on context and specific business needs. For example, a banking system prioritizes consistency. A balance cannot show two different values in different regions. On the other hand, a social media platform prioritizes availability. If a comment appears a few seconds late, it's acceptable, but downtime is not. Modern architectures often blend strategies to achieve the best of both worlds, adapting to diverse requirements. Many systems use eventual consistency, where updates propagate asynchronously and all nodes converge to the same state over time. Others use hybrid approaches like tunable consistency, where developers can adjust trade-offs per operation or service. The CAP theorem is more than just a rule. It's a mindset for thinking about distributed design. It reminds engineers that no system can have it all. Trade-offs are an inevitable part of the design process. Recognizing these trade-offs early helps avoid overpromising and underdelivering in large-scale applications. In a world where distributed computing powers everything from online banking to streaming services, the CAP theorem remains a guiding principle. It teaches us that system design is not about perfection, but about balance, context, and conscious engineering choices.